All right, let's finish up 3-3 here with an actual unbounded problem. So we saw that this one was bounded, and then I filled in this chart here. Hopefully you did as well, and you can just check your work here, or check my work here too, I suppose. But I think I've done everything right there. I found my minimum was -14 and my max was 21. Now, let's go ahead and do an unbounded example. And this example is going to be actually unbounded for reals, and it is 2y plus 3x is greater than or equal to -12. Y is less than or equal to 3x plus 12. And y is less than or equal, greater than or equal to 3x minus 6. And f of x, y equals 9x minus 6y. All right, so let's graph this thing as well as we can. And let's come back to this one for a second. Let's do these two because they're easy here. I go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I go down 3 to the right, to the left 1. Or I go up 3 to the right. But I'm going to, since this is my graph here, I want to go down. 1, 2, 3, 1, 1, 2, 3, 1. Now, I'm not doing this cleanly enough to really be able to make my, to see my vertices. But if you want to do yours clean enough to see your vertices, you can. And I'm going to give you the vertices of this one. So it's okay. Then this one is -6. 1, 2, 3, 4, 5, 6. And notice my slope is the same, 3 over 1. So I'm just going to, for sake of time and all of that, I'm just going to draw it parallel to this one, since they are the same, have the same slope. Now this one here, I'm going to graph this based on the y-intercepts. So y and x and y intercepts. So when x is 0, that goes away. Then I have 2y equals -12. So I divide both sides by 2, and I get y equals -6. So at -6, I have a point for this line. Now when y is 0, I divide both sides by 3. Oh, so when x is 0, y is -6. When y is 0, I divide both sides by 3, I get x equals -4. So there's a point, 0, -6, and 0, -4, 0. 1, 2, 3, 4. Now that might intersect there, I'm not sure. Oh, yes it does. Okay, so they intersect there at 4. And then I have my line that goes like this. And then my region, if I were to, y is less than this one, y is greater than this one, and then y is going to be greater than this one. So here I have my unbounded feasible region. And now I want to show you something a little bit tricky here. So here are our vertices that we're going to plug into our chart. And we just have two vertices, x, y, and 9x minus 6y, and f of x, y. So we just have two vertices. So, and they are -4, 0, right there, and they are 0, -6, right there. And so let's just plug those in. 9, -4, and minus 6 times 0, and then 9 times 0, and minus 6 times -6. Okay, so this is 0, so 9 times -4 is -36. And this becomes 0. Negative 6 times negative 6 is positive 36. Okay, so I've got to, this looks like this area would be called my minimum value. But I need to do a little checking here to see if this is actually a minimum value or a maximum value. And so here's my vertex that is 0, 6. And here's my vertex over here that is 0, 4. Negative 4, 0. Okay. So this one might be my minimum, or this one might be my maximum. And I don't really know which one. I know I'm only going to have one minimum or one maximum. I'm not going to have a min and a max because this goes on forever. So I have to decide if one of these is a minimum or one of these is a maximum, because I can't have both because this is unbounded. So I need to decide which one of these is the one that is a minimum or the maximum. Okay. So let's just choose a point. Let's say 0, let's say 0, 8. All right, so let's plug in 0, 8 and just see what happens. 0, 8. So I'm going to say 9, 0 minus 6 times 8. And let's see what we get over here, and this will help us decide whether it's a minimum or a maximum. 0 minus 6 times 8, which is negative 48. Okay, so we should be able to use this information to decide which of these is a minimum and or a maximum. Okay. 36 is greater than negative 36. So based on these two, this would be a max, right? Negative 36 is less than 36. So based on these two, this would be a min. But we know one of these is not a max and or a min. So we've got to decide which one is going to be the min or which one is going to be the max. Now, here's how we decide. We just plugged in some random number that is inside of this feasible region, and we got negative 48. This is less than this minimum. Therefore, this cannot be the minimum because we have stuff that's less. So if I chose any number in here, it would still be less than 36. So that means 36 is the maximum. I realize that this might be super confusing, but we'll get through it. And that is it for 3-3. Good luck on the homework.